The graph of an exponential function is shown in the figure below. The horizontal asymptote is shown as a dashed line. Find the range and the domain. And it asks us to write the answers as inequalities using x or y as appropriate. Okay, so as we look at this graph, we see there is a horizontal asymptote. However, horizontally, the graph is unimpeded. Vertically, that horizontal asymptote does not allow the graph to extend below this y equals 2 line. So, of course, when we are looking for the domain is the set of all x inputs that we can put into the function. So any x value that we can put into the function that will give us graph. So as we use a vertical line test and move across the graph, we're looking for any point where we see graph along this vertical line test. So as we move along this x-axis, from negative infinity to positive infinity, we're looking for places that would, any of these x values would give us some corresponding y value. So for example, if I have negative 2, I go up and I see the graph hits at this point at x equals negative 2. My corresponding y value then would be here in between 2 and 3. So as I run my vertical line across, first thing I need to understand is what these arrows mean. This means it extends up and out forever, and this means it extends out forever. However, the asymptote means that the graph will never touch or cross that line. So we have a graph going out and up to infinity on the y-axis and out to negative infinity on the x-axis. So from negative infinity to 0, everywhere along here we have graph. And from 0 out to infinity, we see that this line here extends out to infinity but will never cross this. So we still have graph. So every single point, every single x value I can put into this function, and it will have some corresponding y value. So my domain is all reals. All real numbers. Okay. However, when we are looking for our range we would use a horizontal line test. As we go from the bottom and move up, we're looking for area that we have graph. So for example, if I wanted to know if there's a corresponding x value when y equals negative 6, I would look all along this negative 6 value. We see that there's no graph, and it won't hit at any point, even off the graph, because it's not going to extend below this asymptote, and it extends up from there, up and out, so it will never hit this point. So here we see there's no graph. This does not belong to the range. There's no x value that will give us a negative 6. So as we go up, we see there's no graph, all the way until we hit this y equals 2 point. At this line, y equals 2, we see that as soon as we cross it, we have graph. Okay, and we have graph from that point all the way up, and this line extends up to infinity. However, the graph will never touch negative 2. So we can never produce y equals 2. No x value will give us a corresponding y value of 2. So our range then, all values, y is greater than 2. Y is greater than 2. So this right here satisfies what it's asking us to do. The domain is all reals, and the range y is greater than 2.